So first, we have to define the fingerprinting map. To be able to do so, we have to define the RSSI space. So, to define the space, we have to consider the number of access points, which will be named n, so that the RSSI space is an n-dimensional space defined by the RSSI values from the measuring references or access points. Which means that we have for each RSSI space element a vector of dimension n with n RSSI values each from one access point. There might be some elements where you have no value for some of the access points. So then you have to use a pseudo zero value, which will be the minimum value that the sensitivity limit of your access point device is able to receive. So for instance, but you have to adapt to your hardware. If you use Cisco Aeronet access points or Wi-Fi card, your sensitivity limit would be minus 95 dBms, which means that each signal that you can measure and receive is higher than minus 95 dBm, so minus 95 dBm will be your pseudo zero value. So why can't we use zero? Because compared to something in less than zero values, it's a very, very high value, so it's not a zero in the RSSI sense. And we cannot use something too far from the sensitivity limit, so for instance minus 200, because it would give too much importance to missing access points compared to the access points you have in your RSSI space vector. Then, now that we know how to define the RSSI vector and in the RSSI space, what is the RSSI map or the fingerprint map? It's something that we can call a database. Actually, it could even be in a database system. And it contains what we call reference points. One reference point is defined by geographical coordinates, which may be global, such as provided by a GNSS, or local Euclidean coordinates, or something else. You have to define that when you build the system. Alongside these geographical coordinates, you have an RSSI space coordinates, which is an RSSI vector, which might be completed by other data, such as the orientation of the mobile device which performed the calibration of the reference point, and so on. So, for the type and volume of the data in the reference points, we must at least have the geographical coordinates and one RSSI sample. The RSSI sample may be one value, which may be an aggregation, for instance an average value, or several values, or a representation for several values. We'll see after what can be this representation. You also can add additional data, such as orientation. And the more data, the longer the computation, but usually the higher the accuracy. Because you have to process more data and use more complex models, but this can in turn improve your results. So with a single value, you see that we have 3 access points. Here we put 1 reference point in the center of each square. And for each reference point, we store the RSSI from AP1, 2, and 3, so RSSI 1, 2, 3, alongside the coordinates of the reference point. So these RSSI may be issued from 1 frame for each access point, which is not recommended because you could have a bad luck and get one of the extreme values that you can get from your reference point. Or you can measure for a small time, 1, 2, 3, 5 seconds for instance, and average the values of each access point and put the average value in the vector, which is more precise. Then for multi-value, you still have reference points in your grid, for instance, your access points, and each access point will have a distribution. For instance, here we have Gaussian distributions and histogram distributions. So for the histogram, you store the values and their occurrences, so it can be a dictionary whose keys are the RSI values here, the X values, and the values of the dictionary will be the number of occurrences of each value, so the Y value here. For the Gaussian curve, you may use the average value and the standard deviation, which give you this shape and its location in the X coordinate. Of course, you can keep these values, which are the most complete. You have every value from each frame that you measured, and then convert it to average value for a single value system or to average and standard deviation for the Gaussian model. You also can add additional data such as the direction, so seen from above it's your orientation with the mobile device, which can for instance be seen as north, east, south, and so on. The tilt, which is the inclination of the mobile device given the vertical axis. The type of device, because each device has different hardware capabilities and it doesn't behave exactly like the others for the wave propagation. And the antenna diagram, which also helps to understand how the wave is propagating. So to sum up the fingerprint map part, we saw that we have several solutions to use single value, multi-value, and so on. So with multi-value, it can be stored as a statistical law or a data structure. It may be combined and used following your preferences and constraints of the system. So you store the histograms, you compute the average, you get the single value, and you add the standard deviation, you get a Gauss distribution. And these choices will impact your matching algorithms.